Is that a Sasquatch? Woo woo! Hey gang, what's going on? Welcome to the new digs and get ready to watch Finding Bigfoot. So, anyway, I wanted to walk you through a couple of ideas here for the statistics portion that we're supposed to do for the puzzle cube. This is actually a really big idea that you do see a lot of test questions on. Just kind of getting us familiar with some statistics, standard deviation, mean, median, mode, range. Important things that you would do maybe when you're looking at information for gathering data about your parts and your pieces, wanting to know how far they vary in between each other, on trying to find out how exact you're making the parts. Maybe your customer's looking within that range, so you're going to have to look at some of these numbers and figure out what your precision and accuracy is within the numbers and try to find out how great your parts are. So we're going to kind of start off by trying to get all of these things done in our spreadsheet. So really what they want us to do is they want us to measure a bunch of these puzzle cubes. And the wooden pieces that we have here are what you're going to measure. And really the best way to do that is you have to measure a lot of them because we're producing a lot of them in this scenario. And so you got to obviously collect a lot of data to be able to measure a bunch of them. So if you look at the cube itself, you'll notice there's like a lot of really smooth surface outlines because it was made from what you could imagine as a really long piece of these wood, a bunch of these stuck together on all the smooth sides. And then it's really just cut on two sides where you have our grains at. Well, if this whole outside is standard stock, we really don't need to measure that. There's no variation within this standard stock here. The only variation is like the width in which I would cut these two rugged edges. So I need to measure that out. And what you should do is actually, if you can see here, is I measured out 28 of them. Okay, so if you grab your caliper, and mine was just locked in here, we're just going to sync it out, measure it, and get a measurement. And this one looks like it is 0.64 and 10. Well, anyway, you know how to measure and read these now that you took a couple of those quizzes. And we really should get, if you look over here at this data, we really should get a number with 1, 2, and the third decimal points that we're adding within that. Okay, so you're going to do that 28 times with 28 different cubes to get this whole number. Then you're going to want to scroll down and go over to this area here where you're going to start doing your average, mean, median, and mode. Now to do your average, you're going to go your average of your cells. We have 2 through 28 here, or however many you did. Within those cells, boom, press enter, that should give you that number. Median, same thought process. Highlight over, equal sign, median, that'll give you that number. Standard deviation, and just as you can see, standard deviation kind of tells us about what percentage of my parts or population, whatever I'm measuring, actually fits within the data, within the standard deviation. So one standard deviation, you're going to get 34% this way, 34 this way. The next standard deviation, you get 13.6, another 13.6 this way. Two standard deviations is that amount. So we're talking about right here, we got 68 plus another 28. We're talking about over 84% of the population here going in the 90s and 90 percentile. This is obviously a bell curve. So a lot of tests we'll do this kind of standard deviation thought. Here's kind of another example to show you that where this one standard deviation from the mean will give us 68.26% of like the cases that we are measuring, or of the cubes we're measuring, fit within this percentage. And then the next percentage would fit within this next 84% or whatever it is. And then the next percentage would fit within that, and within that to get your total amount. This basically is just trying to show you that when you're calculating your standard deviations, maybe the parts have to be within one standard deviation of your data and they have to be so precise. Or maybe they have to be within two standard deviations. That's kind of where your problem might apply here with that thought process, and that's kind of why we're going through this calculation to kind of figure out what this bell curve is for the parts that you're making. So anyway, when you've gone in and measured all 28 of these, you've gone and done your average, your median, and now your standard deviation. You can just equal standard deviation. You're going to choose population. That's one of the options, or a P. And you can just go through that set there and get this number. Basically what that number says is this much percentage of your cubes are within this variation here. And that kind of tells you how accurate, precise your data is within that. You also want to find your mode. Then you're going to go a mean plus one standard deviation, which is this number, and a mean plus this standard deviation is this number. If you added all these up and you count them, you actually get 23 of the 27 cubes for what I did. This is just my example. You don't have to get these exact numbers. Your examples will be different, but that's about 85% of the cubes fit within one standard deviation, which is actually, if you look back at our example, what we should calculate. So our numbers are supporting each other. Now the tricky part is kind of when we start getting into creating our histogram and trying to show where the cubes fit within these bins. So first thing we got to do is we got to figure out how many entries we have here. And actually, obviously, what you can tell is how many cubes did you measure, which here I have 27. So really, what we need to figure out is what is the lowest number we got and what is the highest number we got in our data. And what you could do is you could just go up here and go equal sign minimum. And you could go through and highlight all of your data, hit enter, and get your minimum. And you could do that for your maximum too. Okay? Not too hard to do that. Now when you got your min and your max, really you want to subtract those and figure out where your range is. So once you do that, basically you want to divide those numbers up into about 7 different sets. Kind of like what I have here. So I have a set of 0.748 was one of my lowest. My highest was 0.772 when I drew this out, or measured it out, excuse me. And 1, 2, 3, 4, probably should have another one on here. But anyway, so you can see there's a range within each of these numbers. So you want to have a 0.743 to 0.748. Okay, that's a range of 0.005. And that was kind of my set value. So I get another range here of that, another 0.05, another 0.05, and another 0.05. And then what I went in and did is I went through these numbers and I counted how many times I had a number within this. This one I got 4, 12, 7, 2, and 2. So the point of the histogram is to kind of get even frequency values or numbers to find out how many cubes are actually fitting within these standard deviations almost of real. Kind of gives us some information about where are the cubes that we're making or other parts that we're making fitting as far as hard numbers into our frequency graphs. Are we producing as many within a certain range as we want? Okay, so I actually included a link to this video if you want as an additional resource to kind of walk you through a little bit of that steps of the parts of the bins. But if you notice, And here I have my bin. So those are what's called your little separation points. You have 0.748, 0.754, 0.760. And then here, my intervals and my frequency all within that are what you kind of want labeled and separated to start creating the histogram. Now what I went over and did is I highlighted this here. I went right click insert chart, and now I can have this data which tells me I had 4, 12 cubes fit within this range. It looks like about 7 within that range. I could go in and change the chart, maybe advance edit, and go in and change the title here. The puzzle cubes themselves is what we're measuring. Your horizontal is going to be your ranges. Your vertical, you can go in and change that. You get frequency. You can also go double clicking on these values. So if you double click over this right corner, go into your series here, that number, you can actually show the value so we can read the frequency nice and easy within that. That's also nice as well, excuse me. And really this is your histogram chart that you're going to include within this data. So I would like to see that as well along with that. I think that's pretty much all that I can think of at the moment as far as what you need to make this histogram along with this mean, median, mode for the standard information. Some analytical statistics. I think it's important to walk through it because you will have a couple of kind of questions about this process a little bit. Not necessarily understanding the deep ins and outs, but kind of the overall overarching ideas about standard deviation and also about maybe like a histogram and what you would have to do for it and what it kind of means that I've seen on the test before. So I hope that's enough. If you have questions, let me know. There's a ton of YouTube videos out there as always, and don't be afraid to ask.